All right, so we're looking at section 4.7. This is on page 108. We're just going to start here with the transformations. This is just a review. We just did this in the homework. We had a couple of problems over this. So notice this. If we replace x in our function with x minus 5, that's going to take our function 5 units right. It's the opposite of what you would think. If we replace the x with an x plus 2, that's going to take us 2 units left. If we add 1 at the end of the function, it takes us up 1. If we subtract 1 at the end of the function, it takes us down 4. This is all review of stuff we did earlier. If we replace our x with a negative x, that's going to be a reflection of the y-axis. If we multiply out the entire thing by a negative x, the entire function, if we do negative f of x, that's going to be a reflection of the x-axis. If we replace x with 2x, that's a shrink by 1/2. If we replace x with 1/2 x, that's a stretch by 2, and these are horizontal. So this is a horizontal shrink by 1/2. This is a horizontal stretch by 2. And then if we have an 8 out in front, that's a vertical stretch by 8, and this is going to be a vertical shrink by 1/4. Does that seem familiar to everybody? We've done that. The only difference now is we've only done this for quadratics and for absolute value, and now we're going to do it for polynomial functions. And we're going to have to multiply it all out and everything. So this one, you wouldn't be allowed to leave it that way. You'd have to use Pascal's triangle to expand it all the way out. Okay. So we're not going to do anything with the graphing on page 109. We're just not worrying about the graphing. We're worrying about the algebra behind it. We will take a look at number 7, though. So on number 7, if we start off with the function f of x, and if we replace the x with x minus 3, what's that going to do to the function? Shift it what? To the right 3. So instead of this point being here, now it's going to be here. And then what does the negative out in front do to it? Flips it over what? The x-axis or y-axis? X-axis. So here we go. It's just going to look like that. All right, so all we're going to do with this is tell what would happen. We're not going to do any graphing with this kind of thing. We're just going to tell what's going to happen. So if the x gets replaced with negative x, what does that do, you guys? Good. So this would be a flip over the y-axis. And then what would happen if we had minus 9? Yep, that's going to be down 9. All right. And then what would happen if we had a function like this and we multiply it by 5? What's that going to do to it? Horizontal or vertical? Vertical what? Stretch by 5. Okay. So the more important thing are these problems down here. You're going to have problems like this to do rather than graphing. So here's our function that's given. The first thing we're going to do is a translation 1 unit left. So that means in my function, wherever we have an x, what do we replace the x with? X plus 1. So I'm going to have to do x plus 1 cubed minus 6 times x plus 1 squared plus 5. Then we have to do a reflection in the x-axis. What does that mean I do to each one of these? Multiply the entire thing by negative 1. So now my function becomes this. Notice how I never go inside the parentheses, because I'm multiplying the coefficient by the negative 1, so therefore this really is already multiplied by the negative, because it's going to get multiplied by the coefficient. And then the last thing we have to do is a vertical stretch by a factor of 2. So do I multiply the inside by 2 at all? No, just the coefficients are going to get multiplied by 2. Oh, we didn't multiply that by 2. So each of the coefficients get multiplied by 2. Now, you're going to have to multiply these all out, unfortunately. This is cubed. So if I'm going to cube this, I can think of Pascal's triangle. It goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So I know that I'm going to have g equals negative 2, and this is going to multiply out to this 1, and then this has to get cubed, plus, now my coefficient is 3, this has to get squared, this is just going to be to the first power, plus 3 again. Now my x is going to go down to the first, and it's really going to be times 1 squared, but that's still just 1. And then plus, and then 1 cubed, no x now, and that's what that multiplies out to. I'm just using Pascal's triangle. This one is going to be plus 12. For this, I want to square it, so I'm going to be using this. So it's going to be 1x squared plus 2x times 1 is just x, plus 1 times, I don't use the x, and I use this squared, which is still just 1. And now plus 10. So distributing this all out, combine your like terms. Okay, that's what we're going to be doing. Any questions on that? Yes, Lizzie?
Earlier, when we multiplied the whole thing by the negative, wouldn't the 5 be negative?
Yes, it would. Thank you.
So then I solved it that way, and it ends up not.
This is not here, right?
Yeah, that can't.
Yep. Thank you. This would have been a negative here too. Yep, so make sure when you multiply by the negative that you do everything. I started talking and then I forgot to do that one. Okay, so now let's look at number 11. So now we have a horizontal shrink by a factor of 1/3. So what does that mean we have to do? Replace x with 3x. So really we're doing this. We're going to be doing f of 3x now. Because if we want a shrink by a factor of 1/3 horizontally, x is going to get replaced with 3x. Then we have to do a translation 8 units down, so that means I'm going to go down 8, and then followed by a reflection in the y-axis. What does that do? Replaces x with negative x. So now I'm really going to be doing this. Do you see how doing it kind of this way, I can kind of save some time? This would be saying to take every x and replace it with negative 3x, and then at the end subtract 8. And I can kind of do it all in one step. I could have done this one that way too, but I just wanted to kind of show you the other way of doing it. So now we're going to have our new function is going to be, wherever I have an x, I'm going to replace it with negative 3x. And then I'm going to have to subtract 8. So this is 81 times 3. Okay? Does that make sense? Anybody else get that same answer? Okay, good. All right, so that's all you're going to have to do on your homework, and you don't have much to do. If you looked at the assignment sheet, it's only like 9, 10 problems.
I If it says drop, do you want us to drop?
I do not.